Assalamualaikum and hi. Okay, let's continue on partial differentiation. For lecture 3 of 3, we are going to focus on extremum of functions of two variables and Lagrange multiplier. For learning outcome, at the end of this lecture, you should be able to solve problems related economics and business. Okay, and then formulate the problem related to maximizing or minimizing z equals to fxy subject to the constraint gxy equals to 0. Okay, D is restrict to linear only. And then for B, determine the critical points xy by solving the simultaneous equations. Okay, do not use the second order partial derivative discriminant to prove maximum or minimum point. Okay, and the last one, solve problems involving economics and business. Example 1. The cost function, which is given as cxy equals to x squared plus y squared plus xy minus 20x minus 25y plus 1500 for inspection of an assembly operation depends on the number of inspection x and y. How many inspection of x and y should be made in order to minimize the cost? Hence, determine the minimum cost. Okay, so for the first one, okay, we want to minimize the cost. So to minimize the cost, the first step, okay, we have to differentiate, okay, the cost function, okay, with respect to x and with respect to y. Okay, so first, okay, let's find c sub x. Okay, we have three terms that have variable x. So c sub x should be equals to 2x plus y minus 20. Okay, let's proceed to the c sub y. Okay, for c sub y, we have three terms. Okay, with variable y. We differentiate, we will get 2y plus x minus 25. For the second step, okay, we use c sub x and c sub y, then we equate with 0. Okay, both derivative equals to 0. Okay, now we have two equations. Okay, so for the first one, 2x plus y equals to 20 and y equals to 20 minus 2x. Okay, for the first equation. And the second one, okay, 2y plus x equals to 25. Okay, second equation. Okay, so we can substitute. Okay, first equation into second equation. Okay, 2 times 20 minus 2x. Okay, plus x equals to 25. Okay, so for the value of x, okay, 40 minus 4x plus x equals to 25. Okay, what do you have? Okay, so for the value, negative 3x equals to negative 15. So your x equals to 5. The last one, okay, substitute. Okay, x equals to 5 into first equation. So your y equals to 20 minus 2 times 5. So your y equals to 10. Let's proceed to step 3. Okay, from c sub x and c sub y, okay, we will find second order derivative so that we can substitute the values into the test formula. Okay, for c sub xx, okay, we have term 2x. Okay, we differentiate, you get 2. Then C sub yy. Okay, look at C sub y. We differentiate, you get equals to 2. And the third one, Cxy. Okay, refer to C sub x. So we'll get 1. Okay, now we want to substitute all the values into the test formula. Okay, for the fourth step. Equals to 2 times 2. Okay, minus 1 square. So we'll get 3. Okay, you get 3. So we can conclude that the D greater than 0 and C sub xx also greater than 0. Okay, so this is a minimum. Let's write the conclusion. So therefore, 5 inspection of x and 10 inspection of y should be made to minimize the cost. Okay, and don't forget we want to find the minimum cost. So this is the function. So we substitute the value of x and y. So x equals to 5 and y equals to 10. Okay, to find the minimum cost. So we will get the value is 1325. So we can conclude that minimum cost is 1325 ringgit. For example 2, if the demand functions for unit of product A and product B are given as P1x equals to 36 minus 3x and P2y equals to 40 minus 5y, the cost function is equals to x squared plus 2xy plus 3y squared. Determine the quantity of x and y to get the maximum profit. Hence, show that the profit is maximum. So in this case, to determine the quantity of x, we want to use, we want to get the maximum profit. That means we have to find the profit function, then we maximize the function. Okay, so profit function, if you still remember, is revenue function minus cost function. Okay, cost function is already given in the question. So now we want to proceed to find revenue. Okay, revenue, you can get it by multiply price and quantity. So for Rx, we can get it by multiply P1x with x. Okay, the quantity. Okay, so you'll get 36x minus 3x square. For Ry, P2y times y. So you get 40y minus 5y square. So we take these two revenue function and we combine, to get the total revenue function. So you should get 36x minus 3x square plus 40y minus 5y square. Okay, from these two function, total revenue function and total cost function for both product. So now we can proceed to find profit function. We minus the two functions. So we get profit function 36x plus 40y minus 4x square minus 8y square minus 2xy. Now we can proceed to maximize the profit. Step 1. We differentiate the profit function with respect to x. So you'll get 36 minus 8x minus 2y. For profit, sub y equals to 40 minus 16y minus 2x. So now let's proceed to the second step. Okay, we want to find the value of x and y. Okay, so we equate both derivative with 0. Okay, we will get two equations. Then we can solve the values. Okay, for the first equation, 8x plus 2y equals to 36. Okay, we can simplify by divide by 2 for x plus y equals to 18. Y equals to 18 minus 4x. Okay, first equation. So for the second one, 2x plus 16y equals to 40. Okay, this one also can be simplified. You will get x plus 8y equals to 20. Okay, second equation. We can substitute first equation into second equation. X plus 8y, so 8 multiplied with 18 minus 4x equals to 20. X plus 144 minus 32x equals to 20. So you will get your x equals to 4. Substitute x equals to 4 into first equation. Y equals to 18 minus 4x, so 4 times 4 equals to 2. Okay, now proceed to the step 3. Okay, we want to use the second order derivative to test the value of x and y. First, we find profit sub double x. We differentiate negative 8x, you get negative 8. Then profit sub yy. Okay, we differentiate negative 16y, so you get negative 16. And the third one, profit sub xy, we differentiate negative 2y, you get negative 2. So we substitute all the values into the test formula. Negative 8 multiplied with negative 16 minus negative 2 square equals to 124. D is greater than 0, 124, and profit sub xx is less than 0. So we can conclude that it is a maximum. Okay, now we can proceed to conclusion. Okay, the question 1 is to prove that the profit is maximum. Okay, the profit is maximum when 4 units of product A and 2 units of product B are produced.